So this is a surprising outcome of the thousand brains theory. Take some small part of the brain that's looking at some small part of the retina, and therefore it's only getting input from a small part of your visual space. And you say, well, how can I learn what an object is? But the key is it's this idea of sensorimotor integration. That your eye is looking at one spot, but your eye is constantly moving 3 times a second or so, and your bodies are moving and so on. And so that little part of the cortex that's getting input from that part of the retina, its input is changing as the eyes move. And so it's sampling different parts of the world, different parts of the object every time your eyes move. And if it knows where it is in the world, it can assemble over time a 3-dimensional model of object. In the same way that you could run your finger over an object. Imagine you stick it in a black box and you're touching an object and you move your finger over the object, you can't see it. You can only sense where the tip of the finger, very little information, but you build up a 3-dimensional structure of the thing you're touching. That is exactly the same as, that's what I was talking about in vision a second ago. It's the same principle. So a column can get a very small amount of sensory information, but if it integrates it over time with movement and knowing how it's moving, it builds this 3-dimensional object. And of course, it needs a reference frame to do that, putting these sensations in some sort of a reference frame. All of that can happen in a cortical column, a very small area of the neocortex. And that's what we believe is happening. So every part of your brain actually can learn complete structural models of structural objects or structural things, complete models of things.
Yeah, so when considering this question, I think there's an interesting thought experiment, which is if you look at a honeybee, this is an insect with a complex sensory motor repertoire. It can fly, it can build hives, it has social structure, and importantly, it can find its way to various locations in the world and figure out how it should move to kind of get back to somewhere it is, which is related to this concept of kind of reference frames that we often talk about. The brain of a honeybee is about the size of a sesame seed. That's about half the size of a cortical column, which is about the size of a grain of rice. So it gives a little bit of perspective in terms of kind of just how much you can achieve given the kind of complexity of neurons with just a bit of kind of neural hardware or wetware rather.
Yeah, another way to put what Gilda said is neurons are really small. And so you can get a little bit of neural tissue, and there's a lot of neurons in there. And if you consider the number of synapses, the connections between neurons, it's incredibly dense. So don't be fooled by smallness in nature. There can be a lot of power in a teeny little bit of neural tissue.